Good morning to all of you. In the last session, in detail, we have discussed about IP addressing, which is Internet Protocol, and in that we have discussed about IPv4, right? So first, I will ask few questions. Those who know, either you can unmute your audio or you can write in a chat. So the first question is, how many classes are there in IPv4? Correct. Class A, Class B, Class C, Class D, Class E. Okay. What is the leftmost octet bit for class B? Correct. Very good. All the students are correct. Leftmost octet bit for class B. B for Bombay. I'm asking for B, not D. B for Bombay. No one? Yesterday I told to note down this. Forum? Answer. It's a 1-0. Okay, what is the range for class C? Okay. So this how you have to remember, as I told, that the types of classes uh, for IPv4, you have to remember the leftmost octet bit for every class. Then you have to remember the range of that classes. And the last question, that class D is used for which purpose? Correct. It is used for multicasting. And class E is reserved for. Yes, correct. Very good. Right? Those who are not giving the answers, next time I will ask randomly to any students. In my every sessions, I am giving a time to note down something. This is the same scenario we are observing in a mid-sem paper answers. Fine. Let's start with today's topic. Just a second, let me present my screen. When I have started the working functionality of network layer. So at that time, in detail, we have discussed about two things, virtual circuit and datagram, right? So today we will discuss what kind of fields will be added once network layer will form the datagram, right? Previously also I have told that datagram and virtual circuit we will discuss in detail. General overview, its functionality, advantage, disadvantage, working, that everything we have discussed, right? Now, what kind of field are added with that datagram, right? So give the title. Whenever it is asked, you have to draw the diagram, like explain IP datagram format. So at that time, you diagram is also having a weightage. Like previously, question was asked, explain data communication. So you have to draw the diagram: sender, receiver, medium, protocol, message, and then have to explain all the entities. But if you will write the theories, the point where the diagram is there, you have to draw that according to the weightage. Like if it is asking a 3 marks, then it's okay. But question is asking a 8 mark or 6 mark. So at that time you have to draw the diagram. Over here again, for IP datagram format, we will discuss every functionalities, right? But before that, you just draw the complete diagram. I know I will provide the PPTs, but at least if you write something, you are able to draw this. So take your 1 or 2 minutes of time. Once you draw that, give me a notification in a chat. I will start explaining. Okay, so I think all of you must be clear on the part of datagram, right? That is necessary. First one, that is a version, right? So it specify whether IPv4 or IPv6, right? Because it is a IP datagram protocol, an IP, that is internet protocol, right? And yesterday we have discussed that for IP protocol, two versions are there. It can be IPv4 or it can be IPv6. And binary representation is also given. Like if you have to represent 4, so that is 0100. And if a 6, that is in a decimal. If you want to convert it into binary, the answer will be 0110, right? What we will do from the diagram, we will go with the every single point, right? I will give the time to note down, because see, you have to make a practice. What another thing we have observed, like you know the answer, but your representation, many of the students representation is very bad, like it's very difficult to read what you have written, because that practice is left. So at least write something, and representation is need to improve. So as I told, if question is asked in a 8 and 6 mark, draw the diagram, then write every point in detail. So first point over here, in the datagram format, that is a version, it can be IPv4 or it can be IPv6. Next one, that is a header length, right? Like we have discussed at a transport layer. With the data packet, it will add the header, right? So that length vary from one sender to another sender. But how much data is included? So that will specify the length of IP header. And the maximum one, that is a 32-bit words. Next point, that is a type of services. So previously we have learned about many terminologies, like a throughput we have discussed, then we have discussed reliability, right? Sometimes bandwidth related, faster access. So there are many points. So again, it depends on the client, that sometimes it need to specify that thing. So that parameters are going to be added at a type of services, right? Go with the third point. It include that informations in a type of services field at a datagram. Sometimes, as I told, faster access means low delay, higher throughput. Yes, tell me, what do you mean by throughput? You can unmute your audio and you can argue the answer. What is throughput?
Amount of data transfers in a particular time limit.
Okay. Throughput is also known as a bit rate, right? Correct. Bits per second transmitted, right? Very good. Correct. So over here again, how much bit you want to transmit, right? If that is unit, if you want, you can specify as a client. So type of services, it depends on the requirement of the client, and according to that can specify in a datagram. Okay. Next one, that is a datagram length, right? How much bytes total will be added in a datagram, that will be specified at this length. So first row is covered over here. Now let's go with the next point. That is a 16-bit identifier, right? Okay. So now over here, identifier are used in a datagram for uniquely identification. Say for example, when one datagram is sent, so initially it will be set by 1 from 0 to 1. Next time another datagram will form, so it will be increment by 1 each time datagram is sent. Now suppose your datagram is very large and you are dividing it into subparts, so that is known as a fragment. But suppose for any datagram, once it is created, you have assigned the value 1 for initially 1. Now suppose you divide that datagram into fragment. So every fragment will contain the value 1 as the identifier. So through that at a receiver end, it can be merged, reassemble that all the fragment of that datagram. If every fragment contains the 1, so it will merge that all the fragment whose value of the identifier is 1. That means that belongs to same datagram, nothing else. From client to the server, from the sender to the receiver. So this is the reason identifier is added in a datagram. Same thing is written over here that this allows the destination host to determine which fragment belongs to which datagram. So note down this point till now up to identifier. If you are having any doubt at any point, you can ask me, right? Okay, now let's go with the next point. So after identifier, now two bits we have to discuss. One is a flag and second one that is a fragment offset. See, first clear on a fragmentation and reassembly. Fragmentation means you will divide your whole datagram into sub part in a small fragment, in a small chunks. And reassembly, fragmentation will be done at a sender host, whereas reassembly will be performed at a destination host. It will merge that all the fragment as a one. Offset is nothing but like a one object where this all the bits will be combined at a receiver host, and at a sender side that fragmentation functionality to perform that we need some object, right? Okay, now let's go with the point over here. First one, that is a flag. So see, when any datagram is divided into sub part fragment. So as a sender, first it creates the datagram, then it will divide it into fragment, and one by one that fragment will be followed in the network. So the question is raised that at the receiver end, how it will identify that this is the last fragment of that datagram, right? So for that one condition is there, like whatever the last fragment of any datagram is there, you need to assign the zero value. So through that zero value at the receiver end, it will identify that okay, this is the last fragment of that offset, right? Because for remaining fragment, as we have discussed in a previous point, that every time that going to be incremented by 1. First value is 1 and remaining time it going to be increment by 1. So this is how clearly we can differentiate for the last datagram fragment. And then receiver will understand that now no fragment have to receive from the client side. Then it will reassemble all the received fragment until it receives the zero fragment. It have to wait, right? Until that it will not reassemble. So first you just note down this point, right? It's take a time to understand. Okay, now let's go with the next point, that is a fragmentation offset, right? So as I told that when any large message will divided into subpart, that is in a fragment. So whenever that message fragmentation will occur, so this field will specify the position. Like suppose uh, for easy understanding, let's take that message is divided into 5 subparts. So that 5 subpart need to specify individually. Okay, this is the first fragment, this is the second, this is third, this is fourth. Ultimately, they are part of same fragment, same you can say datagram or the same message. Say for example, we have divided the students according in a division wise. Like branch is same, that is computer engineering, right? Fourth semester MU. But TC1 division we are having TC2 division we are having, TC3 division we are having. In every division we are having a students. But to uniquely identify the students, what we have done, we have allocated the enrollment numbers. And through that enrollment number, we can easily identify the students. Same way over here, like to uniquely identify the message of that fragment, particular number will be allocated. And the range for that, that is 8 bytes or a 64 bits. Again, just go with the till now points. At any point, if you're having any doubt, you can ask me because many of the points are new. Okay, so no query. So second row is covered over here. Next one, that is a TTL, time to leave. That means maximum number remain hops, right? See, in a network, packets will be forwarded from one node to another node, and every time, like a router will define the routes, right? So, how within how much duration that packet need to be received, right? That is that one value will be set, which is known as a TTL. And when we are running the commands, at that time when we have this seen, observe the outcome. Like if you give the ping command or trace at command, so for that it will give you a TTL, time to leave. The same way you can set the TTL for your datagram. Another thing, it going to be decrement by one when it visit one router to another router. Because see, suppose TTL is fixed, that is 100 millisecond. Within that, it need to reach from source to destination. Once it visit one router, that value is going to be decremented. Then and then we come to know that how much time is remain, right? So this is the mechanism for the TTL, or you can say that time to leave. Okay, note down over here. And as I told that suppose you have set TTL equal to 100 millisecond. Now due to some issues, if that datagram going to be reached to zero and it not reach to the destination. So what does it means? That it has taken too long time, and at that time it going to be considered as a delay over here, and it going to be discarded. Next one over here, that is related upper layer, means the delivery protocols. Now, as we are discussing this functionality at a network layer, so we know that the upper layer for the network layer is, which layer will come after a network layer? Upper layer I am asking. Students, I am asking to you. Correct. Transport layer, right? So over here that field is upper layer. But what it will do? So from the network layer, it have to forward the data to the transport layer, upper layer. Now what it will do? Right? We know that the transport layer provides the services of two protocols. It can be TCP, it can be UDP. One is connection oriented, one is connectionless. So when at a receiver end that packet is received, so this functionality also need to know at a destination end. And to differentiate between this functionality, like a specific numbers are allocated to this datagram. 6 will indicate the data portion is passed to TCP protocol. Many of the students till now not remember TCP contains transmission control protocol. UDP stands for user datagram protocol. And if it is UDP, so number 17 is allocated, and which specify at upper layer that this is a passed through UDP. So note down these two numbers and the functionality of protocol field. Now the next point, that is header checksum over here, right? So checksum functionality is used to identify that whatever the message is sent, that exactly received by the receiver. At a receiver end, is there any bit change, any bit error is there, right? So through the checksum we can identify. So that is the reason header checksum is added over here in a datagram. Basically it is used for error detection. And error detection functionalities will be handled at a two layer, either at a transport or a data link layer. So while we will discuss about data link layer, at that time we will discuss about checksum and how to calculate the checksum. Okay, now let's go with the next point. So as we know that we need to specify the source IP address and destination IP address, right? Who is the sender and who is the receiver? And that is of a 32 bit. Source IP address also 32 bit and destination IP address will be of a 32 bit. Now only two field are remain. First one, that is option, right? So this is like not compulsory for every datagram, but suppose it based on the requirement of the datagram, some field you need to specify like it's very urgent to forward it without load, like you want to urgently forward the check datagram, or some specific things you want to specify. So in an option field we can add that, right? Over here the example is given like a timestamp you can specify. Then like you, if you want that packet should be forwarded through specified predefined path of the routers only. So if that kind of things requirement, so that we can specify at a options field, that your predefined things like every datagram need to pass through that fixed, or you can say that static routes only. And the last field, that is the data, right? The information which you want to pass from client to the server, that will be added one host to another host, that will be added over here in a datagram. So these are the fields, you can say that the part of IP datagram, right? In detail, we have discussed about each and every point of a IP datagram. Now note down this last 2 points. In the message, you can transfer as a one datagram, or you can, as we have discussed, like fragment it into sub part, and then can send, and at a receiver end have to reassemble it. So fragmentation means divide the message into sub part, whereas reassembly means combine that sub part into one is a datagram. This is a two different term or terminologies which are used in a datagram: fragmentation and reassemble or reassembly. Meanwhile, let me start the attendance. 917109,
Yes, ma'am.
180, 222, 222, 41,
Yes, ma'am.
68,
Yes, ma'am.
69,
Yes, ma'am.
70,
Yes, ma'am.
71,
Yes, ma'am.
73,
Yes, ma'am.
74,
Yes, ma'am.
75,
Yes, ma'am.
76,
Present, ma'am.
77,
Yes, ma'am.
78,
Present, ma'am.
79,
Present, ma'am.
80, 81,
Yes, ma'am.
82,
Present, ma'am.
83,
Present, ma'am.
84,
Present, ma'am.
85,
Present, ma'am.
86,
Present, ma'am.
87,
Yes, ma'am.
88,
Present, ma'am.
89,
Present, ma'am.
90,
Present, ma'am.
91, 92, 93, 95,
Present, ma'am.
99, 100,
Ma'am, 99.
101,
101 present, ma'am.
okay, 102, 102, Shruti, 102, she is not present. 105,
Present, ma'am.
106,
Yes, ma'am.
108,
Present, ma'am.
109, 111,
Yes.
112, 130,
Present, ma'am.
133,
Present, ma'am.
150,
Yes, ma'am.
155,
Present, ma'am.
92 series 1,
Present, ma'am.
2, 3,
Present, ma'am.
4, 5,
Present, 5.
6,
Present, ma'am.
7,
104 present, ma'am.
okay, 7,
Present.
8,
Present.
9,
Present, ma'am.
10,
Present, ma'am.
11, 13, 15, 16, 17,
Present, ma'am.
18, 19,
Present, ma'am.
20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
24,
Present, ma'am.
25,
मैम उसका माइक बिगड़ गया है प्रेजेंट है 25
41,
Present, ma'am.
42, 44, 45, 46,
Hello, ma'am.
हाँ,
0404.
yes, 47,
Present, ma'am.
Hello.
48,
प्रेजेंट मैम
49, 50,
Yes, ma'am.
okay. Thank you all of you. You can leave now. Have a nice day. Be safe at your home.
Ma'am,
Yes,
ma'am, C 99.